Hi, this is Phil from Simply Rhino, and in this short video I'm going to take a look at creating a part animation in KeyShot 10. This is an animation where we can move the model or parts of the model against a timeline. The starting point is going to be in Rhino 7 and with this engineering model of a dewatering pump. In Rhino 7 we can animate the camera but not move the model or parts. So, if you have KeyShot, this opens up the possibility of creating easy part and keyframe animations. All of the steps in this video are fairly straightforward. However, I am going to look at how we handle the case where a rotating or hinging component is inclined at an angle, i.e. not in line with KeyShot's X, Y or Z axes. So, if you've come unstuck with custom rotations in KeyShot in the past, there's a workaround included later in this video. Let's now take a look at the finished KeyShot video to see what we're aiming for. The video starts with the main yellow engine cover being raised up whilst the side door opens. At the same time, the model is rotated. A pump impeller component is moved forwards to expose the pump detail below before this and the yellow cover fade out. Finally, there's a camera movement so we can see down into the pump and engine assembly. Before I go further, let's take a look at the KeyShot interface with the completed animation. In the animation window at the bottom, you'll see that I have 8 animation elements that start and finish at various points in the timeline. Once these are created, I can see and edit their properties in the window in the bottom right. I can also scrub through the timeline to get a quick idea of how my animation is progressing. Let's go back to Rhino now, and first of all I want to look at how this model is organized. For still images, I would usually use Rhino's layers to separate out the components on a per material basis, as this would make it easier to apply the same material to multiple components in KeyShot. However, here I'm going to use sublayers, or parent and child layers as they are sometimes called, to contain, for example, all the components that are included in the engine cover assembly that I want to hinge upwards in the animation. The other thing I want to do in Rhino is to create a helper object that will make it easy for me to hinge this side door that is inclined at 5 degrees to the vertical. I'm going to hide the hinge pin, and then I'll create a straight line that snaps between the top and bottom of the hinge centers. This line is of course inclined at 5 degrees to the vertical, and I'll now mark the center of this line and rotate it about that center by 5 degrees so that it's now vertical. Finally, I'll use the pipe command to create a simple solid from this vertical line and push the resulting solid onto its own layer called helper. Now, this may seem a strange or unnecessary procedure, but the issue in KeyShot is this. When I pick a local hinge point on Rhino geometry in KeyShot, for example the center of this line, then KeyShot will only recognize a point in space for rotation, and any such rotation will be relative to KeyShot's X, Y and Z axes. In order to get around this, what I need to do is introduce an object into KeyShot that has a center about this point. I can then rotate the object in KeyShot, and once rotated, KeyShot will then understand the relative rotated X, Y and Z directions of the part, and I can then use this to describe the axis of rotation for, in this case, my side door. So, once I have my helper object completed and I've checked through all the layers, then I can go to my KeyShot 10 live linking plugin and I can send the model to KeyShot. Okay, so the model is now in KeyShot, and first I want to set up a few basic things. I'll go to Image here, and I want to make this image the same ratio as a 1920 by 1080 HD image, which will be the final video output resolution. So I'll set this to 960 by 540. Next, I'll go into Lighting and choose Product. Then I'll go into Environment here and I'll use Overhead Array 4K as the lighting setup, and in the Environment tab on the right, I'll choose a white colour for the background. I'll turn on the ground reflections, and in Scene, I'll pick the complete model set, go to Position, and make sure that this is snapped onto the ground. Next, I'll go to Camera and I'll manipulate the view to give me a starting position. And I'll save this camera position as Animation. Now I can start adding materials to the scene, so I'll expand the model set and you'll see we have exactly the same layer configuration here as we did in Rhino. I'll go to my materials on the left and select Metallic Paints, and I'll drag the metallic yellow paint onto the engine cover. I'm just going to suppress some layers here, and let's leave on side door and the main bund fabrication. Now, I'm going to have the same grey material on the side door as on the grey part of the bund fabrication. And of course, I want to avoid creating duplicate materials. I'll first apply this standard grey paint to the bund fabrication. Now, if I drag from the library again to the side door, then I'll get a duplicate grey material. But if I go to my material selection down here and drag the material from here, then I won't create that duplicate. Okay, so now I've added all the materials I want to add, and it's time to start creating the animations. And if you don't see the animation window at the bottom here, you can get this by going to the Window menu and selecting Animation. I'm just going to go to the side door here and turn off that helper object so I can just see the parts that I want to animate. The first area I want to look at is the yellow engine cover. The geometry for the hinges exists in the model, so we can use the hinge pins as a rotation point in KeyShot. I'll go to the Animation wizard and I'll pick Rotation. Then I'll go to Next, and then I can specify the part of the model that I want to animate. And this is the main cover here. The next panel is where we actually set up the animation. And the first thing I need to do is to define a pivot point. So I need to select Pick, and then go to Main Cover, and then go down to Pin, which is the controlling layer for the hinge pins. Now there's actually two of these hinge pins, but KeyShot will just work out the center of those two objects. I'll select 70 degrees for the rotation, and I can choose Ease In and Ease Out, which means that I'll get a sort of a damping down of the movement at the start and the end of the rotation. I'm not going to worry too much about the time or the duration here, because I can do this by dragging in the timeline later. So I'll close this window and I'll drag out the animation to 15 seconds, and if I scrub the timeline, I can see the animated object. So now I've got the first part of the animation done, and I'm going to look next at creating another rotation animation, this time for the side door. And remember that this is the part that is inclined at 5 degrees to the vertical. So first of all, I'm going to turn on the helper object that I created earlier, and then I'm going to turn off the other elements in the model. I'll go to Camera and choose Free Camera so I can manipulate the view, just so I can see everything a little easier. Then I'll go to the Move tool, pick Rotate, and select the helper cylinder as the pivot object, making sure that I have local axis and center pivot point selected. I'll now see the rotation gizmo is aligned to the helper, and I can now rotate the helper by -5 degrees in Y. Now I can add in the animation using the helper object as the axis that I want to rotate about. I'll open the animation wizard and choose rotation. The part I want to rotate is the whole of the side door assembly, and for the pivot point here, I want to go to Pick and select Helper and choose the actual geometry on the sublayer here, the helper object itself. I'll rotate about Z and I'll choose -70 and hit Finish. If I scrub through the timeline, it's a little difficult to see, so let's switch to a free camera and then enable the geometry view and manipulate around here a bit so I can confirm that I've got the axis of rotation set correctly. That all looks good, so I'll go back to the animation camera and I'll adjust the length in the timeline. I want the animation to end at 11 seconds, so I'll drag the end out here, and I want it to start at 4 seconds. So that's the second part of the animation done. Let's look now at some of the simpler elements in the animation. You can see that as I scrub the timeline marker here, the engine cover raises upwards, then it moves out of the frame. Now, I am going to change the view a little later on, but I still don't want to see the cover chopped off like this. So, what I'm going to do is to introduce a fade, and I'm going to start that fade at 8 seconds. If I move the timeline marker to 8 seconds, and then go into the animation wizard and choose fade, then that fade animation will start at where the timeline marker is, so at 8 seconds. The part that I want to fade here is the main cover, and that's all the components inside the main cover. And I'll go to Next, and I want to give this a duration of 5 seconds. And I also want to fade from the default 100% to 0%. I can now see this fade as the cover moves up, and it's already looking better. I'm going to change the title of this element here, and I'm going to call this 003 Cover Fade. I can do this over on the left-hand side here, or I can pick the actual animation element and change the title here. It doesn't matter which I do. Next up, as the cover raises up, you'll see in a moment that there is a box here which sits on top of the front coupling for the pump. And I want to move this box forwards so I can see some of the impeller casting underneath. I'm going to do this with an animation called a translation, which is very simply a movement of the part. And I want to start this at 9 seconds. So again, I'll move my timeline here and go to the animation wizard and select translation. The part that I want to choose for this is in pump installation, and it's called front coupling box. I'll see it highlighted here. Then I'll go to Next, and I can then set the parameters for this. Now, I want to move it about its own local origin, and the translation therefore will be in the y-axis to move this forwards and backwards. To move it forwards from the pump, I know that from previous movements in the model, I need a minus value here. So I'm going to move that minus 900 millimeters, and the duration for this is going to be 4 seconds. I can ease in and ease out if I want, and I'll hit Finish. Let's take a look at this and drag through here, and I can see that part coming forwards, and that all looks okay. I'll just change the name of this here to 004 Move Front Coupling, and then I'm just going to move this full animation forward slightly so that it starts a couple of seconds earlier. Next, I want to do something similar with this that I have with the main engine cover, and that is to fade it out. I'll start that at 9 seconds and go to the animation wizard and select Fade. Then I'll choose the part of the model set I want here. So it's pump installation front coupling box. And I want this to have a 4-second duration, and I want it to fade from 100% to nothing. I'll rename this as 005 fade front coupling. What I want to do now is to rotate the whole object slightly so that as the animation progresses, I start to see the assembly a little bit more from the front. To achieve this, I'm going to add a turntable animation. So I'll go to the animation wizard again and I'll choose turntable. What's important to understand here is that I'm animating the object, not orbiting the camera around the object. I want to start this turntable animation at 0 and I want to have a 13-second duration. The center of rotation is going to be the center of the model, and I want to go counterclockwise. I'll just try rotating by 20 degrees so that it's a fairly subtle movement, and I'll finish. So I'll finish that animation segment and see how this looks. The end shot of this animation is going to be with the camera looking down onto the pump and engine assembly. And to achieve this, I'm going to do 2 separate camera animations. I'm going to start by tilting the camera upwards so it's looking down onto the pump and engine assembly. And then, to make sure that the model stays in the center of the frame, I'll create a translation to move the camera across the model. I'll start with the incline element of the camera animation, and I've got my timeline marker set at 7 seconds, which is where I want the animation to start. I'm going to open up the animation wizard and I'm going to choose inclination. And you can see what happens here with this little animation at the bottom. The camera pivots around its target. The camera that I want to choose is of course the animation camera. And I want to start this at a bit later than I just said. So let's say 8 seconds. And let's give it a duration of 10 seconds, which will make the animation slightly longer overall. The rotation that I want to end up with here is going to be 30 degrees. Now to see this and adjust this, I can move the timeline marker with the animation wizard active, and I can see the camera starting to move. So I can kind of rein this back a bit here, and I'll set it to 30 degrees. This is the view I was looking for, but of course I need to be seeing the model further up into the frame, and I can do this with a separate translation. So let's finish this and rename this element 007 camera incline. Starting at the same point, I now want to add the second camera animation here. And I want this to be a translation, and again, it's the same animation camera that I want to use here. I'll set the global axis here, and I'll keep the start at 8 seconds. This was defined by my timeline marker position, and I want to have a 10-second duration. I'll move the animation wizard out of the way and scrub the timeline marker to the end of the animation segment, and then I can choose my Y value here. Now the slider will respond to the initial starting number here, and 1 is too small, so I'll start with a value of 300 and then start moving the slider whilst watching the result update in the preview window. I'll end up with a value of 670 here, which puts the assembly in the middle of the frame. Let's finish that up, and I'll rename this element 008 Camera Translate. I can render out a preview of the animation by using this little button here. And this will create a small animation which is more detailed than the live preview window, but takes considerably less time to render out than a full animation. Let's fast forward to the end of the preview creation, and I can now play the preview and check that everything looks okay. So that all looks good, and you'll see also that I can scrub through the timeline in the preview too. This preview can be saved for reference. You might want a colleague or client to see this, for example, and this can be done by clicking on the Save icon here. So when I'm happy with everything, I can render out the animation. I'll go to Render and select Animation. And I want to check that I have the correct output resolution set here, 1920 by 1080. I can render out either the work area, which is between these two triangular markers in the timeline, or the entire animation. But in this case, that produces exactly the same number of frames. I can output either as a pre-packaged animation or a set of numbered still frames. I generally favour just outputting frames, as this lets me add corrections and adjustments later by automating Photoshop if necessary. I can set the file type and the quality here, and I can either add this to a queue to render later or render this out immediately. So that's about all I wanted to cover in this video. Thanks for watching, and please feel free to leave any comments below. If you found this video useful, then please hit the like button. And remember that to keep up with all the latest developments in Rhino and KeyShot, then you can subscribe to this channel. At Simply Rhino, we offer training for Rhino and all its key plugins, including of course KeyShot. So check out our website for more details. Thanks again for watching, and I'll catch up with you in the next video.